This is Piecewise Functions Day 3. Today we're going to be starting with step functions. And within step functions, there is a specific function called the greatest integer function. The greatest integer function has a unique notation. It's a double bracket. So you draw a bracket and then draw kind of another line in there. Bracket and then another line. The greatest integer, oops, sorry, I forgot to show you. Bracket with an X and then another double bracket. The greatest integer function means that we want the greatest integer that is less than or equal to whatever we put inside. So less than or equal to X. I'll give you an example. If I put 0 into the function, the greatest integer less than or equal to that is of course 0, because 0 is an integer. But if I put 0.2 into the function, the greatest integer that is less than 0.2 is 0. Same would go for something like 0.7. I go to that next integer less than that number, which would still be 0. It's going to continue being 0 until we cross the threshold of another integer. So now if we put 1 in, the greatest integer less than or equal to 1 is of course 1. So 1.5, we would go down to the 1 right below, which would be 1. 1.99, the greatest integer less than that is still 1. And we don't cross over to 2 until we actually get to 2. Now you have to be careful when you're doing negatives, because you got to think kind of on a number line, you're always thinking to the left. So for instance, if you want negative 1.5, the greatest integer less than negative 1.5, what integer would be to the left of that on the number line? Well, that's negative 2. So you always got to move left. Negative 1.8, also negative 2. Negative 0.5, what integer is less than or equal to negative 0.5? Negative 1. Okay, and then just some crazy random negative number, negative 7.3. The integer that would be less than that would be negative 8. So notice all of our outputs on that side are all integers. When we go to graph this, it gives us a graph that looks like stair steps, and that's why it's in the step functions category. Let's take a look. At 0, 0, we would have a point. Then everything, and I'm going to make my scale by 0.5s just so you can see the steps a little bit more easily. So it's going to stay 0, we said, all up until we get to 1. Okay, so 0.2 is 0, 0.7 is 0. All of these numbers are going to be equivalent to 0 until we get to 1. So at 1, it's not 0 anymore, so we'll put an open circle there. And at 1, it jumps to 1. So we have this little stair step. Now at 1, it's 1 until we get to 2. So we have the closed circle, the horizontal bar that tells us all the numbers between 1 and 2 are going to be 1. But then at 2, it jumps to 2. And this pattern will just repeat until it goes all the way off your page. Maybe I should say off your graph. 2, 3, 4. And then the same in the opposite direction as well. So anything between negative 1 and 0 is negative 1. Between negative 2 and 1 is negative 2. Then you'll see that that pattern repeats all the way down. Now we can see this on our graphing calculators as well. So I want you to grab your graphing calculator and we'll talk about how to do a step function on there. If you ever need to pause the video to get caught up, just hit pause and then join us after you're done, because I'm going to show you the instructions for the graphing calculator. Pretty simple for this first part. On the graphing calculator, we're going to first go to mode, and mode is right next to your second button. So we're going to hit mode, and we want the dot mode. So if you'll go down to where it says connected or dot, arrow over to where it says dot, and then once the cursor is flashing on dot, hit enter so the dot is selected. Okay, then we're going to hit y equals. And so your y equals screen should look like this. Then we're going to go to math. Math is right below your alpha key. Then it says to do number. So at the top, arrow over to where it says number. And then we need to choose the greatest integer function, which is abbreviated int x. That's option number 5. You can arrow down to number 5, or you can just hit the 5 button and it pulls that number 5. Now we can't just use that function without anything inside of it. So remember, we put an x for our variable inside of it. And then after we do that, we're going to hit graph. Now, depending on what you had done previously on your graph, you may or may not see anything. So like right now, I don't see anything on my screen because I don't have the standard viewing window. To get the standard viewing window, I'm going to hit zoom, which is right in the middle, and then 6, because that's standard. And when I do that, it gives me my 10 by 10 window. And then I can see all the stair steps that we just graphed on our graph. Now you'll notice your graphing calculator doesn't do the open circle, closed circle thing. So you have to be aware of that. But it does show you all of those little stair steps for our greatest integer function. All right, let's try graphing another step function here. This is not the greatest integer function, but you'll see it is formatted like our piecewise functions that we've been studying. And we have talked about what happens when there is just a number here without any variables. It's going to be a horizontal line. So this tells us that from -4 to -3 on our x-axis, we're going to have a horizontal line at 1. So I know I'm going to have to go to -4 on my x-axis. Again, I'm going to make my scales go by a half so that it's easier for me to see the steps. So it says from -4 to -3, it's going to be a value of 1. So at -4, I'm going to go to 1. It's equal to, so I'm going to put a closed circle there, draw my horizontal line, open circle at -3. Now, it doesn't always have to be closed circle, open circle like that, so I have to really pay attention because I could have switched those and this side would have been an open and this side would have been a closed. All right, then it's going to be 2 from -3 to -2, so I'm going to go to -3, closed circle, -2, open circle. Then I'll jump up to do the 3 from -2 to 1, and the 4 from -1 to 0. Now, unlike the one we did before, this one does not continue. There should only be 4 steps because there's only 4 lines of our piecewise function. So we're not going to keep going off the graph in either direction. After we get those 4 steps done, we're done. All right, next we're going to take a look at a word problem. So kind of working backwards, the graph is already made for us, and we're going to see if we can read it correctly. Center High School held a 4-hour fundraising pledge drive. The students organizing the drive counted the total money raised at the end of each hour. The results are shown in the graph. How much money had the students raised after 2 hours? So we would go to 2 hours, and we would go up. we see this open circle at 400. That means that's not included. So they must have raised more than 400. So we keep going up until we get a closed circle, and it looks like they raised $1,000 after 2 hours. How much did they raise in all? Well, where's the highest point on our graph? Way up here, 1,800. What is f of 3.5? Well, f is our function. 3.5 is what you're inputting. So 3.5 would be hours. So we would go to where it has 3.5 hours and then go up on our graph to see the value at that point. And it's right in between 1,400 and 1,600. So we can infer that that would be 1,500. On what interval does f of x equal 400? Well, let's see where our function equals 400. Looks like it's from 1 to 2. In an interval, we talked briefly about it the other day. When it's a closed circle, you're going to use a bracket. So we have a bracket starting at 1, and then an open circle at 2 with a parenthesis. So open circle is a parenthesis, closed circle is a bracket. What's the domain of our function? Well, our domain is our x values. So what x values do we have? Well, time is continuous. So time, we have all of the time in between 0 and 4. So we can write that in an interval. Starting at 0, because it has a bracket, it's included. Ending at 4, 4 was also included, so another bracket. What is the range? We know ranges are y values. Do we have, and it's total dollars is range, do we have every dollar amount between 0 and 1,800? Hopefully you said no, because we only have these 5 specific dollar amounts. We don't have any in between because they didn't count the money until the end of the hour. So even though time was continuous all the way across, dollars raised was not continuous. So we can't do a range in an interval because it's not continuous like that. Instead, we just have individual range values. There's a lot of different ways that this is acceptable to write. When you have individual range values, I'm okay with you just listing out what those ranges are. There is a fancy way called set notation that we will learn later, but for now, we just have a value of 0, a value of 400, a value of 1,000, 1,500, and 1,800. So those are the 5 possible y values that we could have. All right, lastly, we want to see how we can graph piecewise functions on a graphing calculator. And so in your note packet, you should have a keystrokes sheet that looks like this, graphing piecewise functions with a graphing calculator. So in order to do that, you're going to actually have to have a graphing calculator or borrow one. But it lists out all of the steps, step by step, for you to use, entering that in there. So give that a try. If you need some help, if you get stuck somewhere, come see me. But it's much easier for you to kind of read through each one and try it than me to try to walk you through via video. But this is definitely something you need to do, and make sure that your screens, when you're doing it, match these screens. Don't try to just guess and do it on your own, especially when you get to the compound inequality. You have to put that in a special way, and it's not how it looks. So be careful when you do that. And then make sure your graph at the end looks similar to this graph at the end. But read through all those directions very specifically. Try it with your graphing calculator. If you have any issues, come see me.